Hello everyone, welcome back. So let's continue about the JVM. Okay, so we know how the JVM is working, right? How it is getting the source code and how it is compiled as a bytecode with the help of compiler, and then it is passed on to JVM. Then we got the output. Okay, so from the bytecode to the output, there will be architecture which will take in your multiple steps of process. Okay, let's talk about the architecture about your JVM. Okay, so here is an example. In previous example, you start with .java file because that is a JDK which developing a Java file and compiling them and then sending it to JVMs. But here the input is class file. So, so once the class file is received, what will happen? There are multiple layer of process has been done in order to show or execute the output. The first thing, the class loader. And then we have another layer which contains method area, heap, stack and PC register and some native method stack. So these are all inside JVM memory. And after that we have execution engine, native method interfaces and native method libraries. Okay, so we're gonna talk about what is method area, what is heap, what is stack, each and everything, because if you know this is my architecture of JVM, right, you need to know what each and everything is doing. Then only you should be able to understand how the basically see, just writing a code is not a big deal. We need to understand how it is working in the background. Okay, so how it is working? The first thing, class loader. So what actually it will do? You can have the answer in the name itself. It reads the class file and save the bytecode in a method area. Correct? Method is the next step. Okay, so whenever the class file given as an input to a JVM, the class loader will load the class, okay, and send the bytecode to the method area, which is the next step. So what method area is exactly is doing once it is received from the class loader? Correct? This is the place where you can store all the class level information of each class. For example, if you're sending thousands of class files, right? So there is a guy we need who can handle all the details. When you have a lot of students, you have the attendance, right? Or you have a student details database, right? The similar when we have a classes, we need someone to take in care of to handle the information about each and every classes. So the method area which will take in care of that particular work. Okay, so the next one is heap. Okay, so what is heap? Normally heap is belongs to a memory. Correct? So this will define how to allocate the memory to an objects. Okay, for example, int I is equal to 10. So you need to specify some memory allocation to that particular x variable, right? So that part will taken care in the heap area. Okay, and stack. So basically it is used for storing temporary variables. So they will be destroyed once the method execution is done or class execution is completed. Right? And then registers, PC registers. I don't have to explain that. We all know what is the use for registers, correct? So the register which will hold the brief step about the execution part. So what needs to be done and what is going to be executed next, and after the execution what needs to be done. So each and everything is registered in this particular area which will hold the execution flow of a class. Correct? For example, we know that, right, Java is running in a multiple threads or single thread and multiple thread, because basically it's a thread, right? So whenever you are dealing with the threads, each and every thread which has its own PC register. Correct? I have a one register or one thread which handles two class files. So that particular thread has a PC register which will handle those two class execution information. Right? And the next one is native method stack. So basically it will use to access the runtime data. Correct? Because there are times you will provide the runtime, I mean you will provide the inputs to the execution of the method. Okay, so for example, you want to provide 10 as an input and you'll provide one more input 20. So I want to know what is 10 plus 20. So those data has been fed to the JVM on the runtime process. So that will taken care of the method stack and the method interfaces. So what basically the interface means is it's a transform layer between two systems or two things, right? So this will enables to call or called by a native application. You can call your Java program from your hardware, right? Or you can call using a programmer, you can find out how many RAM is available in my machine. You can use a Java program running, what kind of thread is running right now. So you can track all this information. So garbage collection. So he is the endpoint actually. So he is the one taking care of each and every variables or memories or objects. Once it is done, it is garbage collector responsibility to destroy them and to clear the memory management. So the memory has been cleared, so then it will be ready for taking care of other data. Okay, so this is all about JVM. Let's meet in the next video. We'll talk about the other topic.